It's going to be another worked out example for an improper integral problem. We have the integral from negative infinity to positive infinity for this expression right here. First thing I'm going to do is I'm going to figure out the antiderivative of it really quick. It's really similar to the last one we did. I'm going to use u substitution, and this is going to be the most varied function, so that's going to be our u. So we end up with a simplified integral to be 1 over u squared. So I'm basically going to be using this up here for this problem. Okay, next thing I'm going to do is you should notice that this improper integral is kind of weird because it goes from negative infinity to positive infinity. The rules we went over for improper integration aren't going to allow us to use values like this. So I'm going to rewrite this integral to be going from negative infinity to 0. I'm just picking 0 arbitrarily. It doesn't really matter what you pick. Now, since I'm going from negative infinity to 0 and it's for x, I'm actually going to write it in terms of u right here. So instead of 0, if I put 0 squared plus 1 in for this u equation, this 0 ends up becoming 1. So I'm going to erase this really quick and put in a 1. And we're going to be going from 1 over u squared. I'm going to actually rewrite this to be u to the negative 2 power, just so it's a little bit easier. And then I'm going to add this integral to continue from 1, but then also go to infinity of u to the negative 2 du. Now from here, it's just solving like any other integral. I'm going to rewrite this using limits because that's technically what you're supposed to do. So I'm going to say it's the limit as a approaches negative infinity for this u to the negative 2, but I'm actually going to do the antiderivative for it. So it's going to be negative u to the negative 1, and we're integrating this from a to 1. And then I'm going to add this to this value over here. So now this time we have a limit as b goes to positive infinity for negative u to the negative 1, and this time we're going from 1 to b. Okay, this is one of our integral properties. You probably learned that in Calc 1, so that should be a little review for you. All right, so from here I'm going to use the first fundamental theorem. I'm going to plug the 1 in here, so you're going to end up with negative 1. Then I'm going to plug the a in here, but the a is going to negative infinity. So now you're going to have negative 1 divided by negative infinity, which is just going to be 0. So I'm just going to add a 0 here. Plus, so that's this first part. The second part, I'm going to do the same thing. I'm going to plug b in here. B is going to positive infinity. So you're going to have negative 1 over positive infinity, which is 0, minus, and then you plug 1 in there, and it's going to be negative 1 over 1, which is just negative 1. Okay, from here, it's just basic simplifying. This becomes 1. 1 plus negative 1, so that's just basically going to cancel out over here, and you're going to end up with 0. So the answer for this improper integral would be 0, because because it has a finite value for its limit, you would say that it converges. So I'm just going to write that it converges. Again, not really part of the answer, but it's a good concept that you'll need to know for later on in the class. Also, real quick, I wanted to kind of show what this ends up looking like if you graphed it. So we have the graph right here. Kind of cool looking. And if you notice right here, I took the integral from 0 to a very large number, so that's almost like taking it to positive infinity, and you get 1. So if you have actually found this area right here, even though it's approaching 0, it ends up becoming a finite number. Oh, and also this is important right here. This tells you the horizontal asymptote is 0. All right, so for this one right here, we're also doing negative infinity. So I'm going to put negative, a large number in here, going to 0. I used 1 in the when I wrote it down, but it doesn't actually matter as long as the numbers match. And you'll notice that you get negative 1. If you just replaced this one right here, we'll just do this, we'll copy and paste it over here. If you just replace this bottom number right here with an exceptionally large negative number, you're going to end up with 0 as well. And I didn't even go to infinity. I just went to whatever this value is, and the calculator basically overloaded and put 0 in there. But you can see that this area over here and this area right here are basically going to cancel. And so the graph kind of matches with what your understanding was with what we did. So that's basically a worked out example of an improper integral. If you have any questions about anything in this video, let me know.